Okay, so they say find the area between those two curves on certain interval. So what I want to do is just draw the picture, and it doesn't have to be accurate, enough for, I'd say, to understand what the question is. And the sine function looks sort of like this. And by the way, I know it goes on, but I just want to stick around the area where pi over 4 to pi would be. And pi's over here, by the way. Now pi over 4, this is pi over 2, pi over 4 will be over here somewhere, all right? Then the question is, what does the cosine curve look like between that region? And the cosine curve looks like this. And it goes through there. They actually equal each other there. Goes down like this. And it comes over here like that, all right? So what I'm looking at two curves. I'm looking at the cosine curve, and I'm looking at the sine curve. And what they want to do is the area. Let me put these points down for you. The point over here is going to be where x is pi over 4. And over here, there's a line over here is where it's stopping, and this is where x equals pi. And I'm noticing that this is the region they're talking about now. So what I want to do is, again, the representative rectangle, something like this. So I'm ready right there at the integration down. And it's going to go from pi over 4 to pi. They're nice numbers, by the way. And what do you get there? Upper curve is actually the sine curve. So it's going to be sine of x minus the lower curve. And again, we're doing the height of the rectangle. The bottom of the rectangle is going to be the cosine of x. Then what? The differential, how wide is that? Dx. All right, we're ready now to do the integration. The antiderivative of sine would be minus cosine. Minus the antiderivative of cosine is sine. And then we take the limits of integration, pi over 4 to pi. And yeah, we got to do the arithmetic now. Let's see, upper limit. Now, the cosine of pi is minus 1. Minus a minus 1 is plus 1. Minus the sine of pi is 0. Now it's going to be minus the lower limit. And it's going to be pi over 4. So minus 1 over root 2. Minus 1 over root 2. What do you get there? 1. Right, because 1 minus 0 is 1. Then you get plus 2 over root 2. By the way, for me, that's a fine answer, but I want to, maybe simplify a little tiny bit. And the way I'm going to do that is rationalize this number over here. So root 2 over root 2. All right, what do you get there? 1 plus 2 root 2 over 2. Well, this cancels off. We left off with 1 plus root 2. Put a box on it. I'd leave it that way. What I mean by that is it's an easy number to look at. This is what we're looking at over here. They wrote it as root 2 plus 1, but really 1 plus root 2 and root 2 plus 1 is the same thing. I also would look at the integration of the problem. And what I mean by that, are we getting what they said we should get? And I got that over there. The antiderivative, we got that part over there. I'm not showing you the arithmetic, but we work through that if you need help with that. And that's what we get, all right? They also approximate it. If you want to, you can approximate it too. Not bad to do. Thank you.